Why is R-squared rarely used to measure model performance in time series analysis?
Time series prediction is a numerical prediction task where we try to predict the next value in the time series based on its past. There are a number of measures to quantify the quality of a model with numerical outputs, and they are all based on the concept of error for the single prediction. That is, they are based on some kind of distance between the target value yi and the predicted value f of xi. Classic examples of error measures are the mean absolute error, the mean squared error, the root mean squared error, the mean absolute percentage error, and of course the R-squared error.
The R-squared measure, however, is rarely used in time series analysis. Why is that?
Time series are often non-stationary. The statistical properties of a non-stationary time series change over time. That means that the average value is not constant over time and the variance value is not constant over time. Now, the R-squared expression includes this ratio between the sum of squared errors and the estimated variance for the sample set. The idea is that the larger the sum of squared errors, the farther I am from explaining my data set. This leads to an R-squared close to 0. On the opposite, the smaller the sum of squared errors, the closer I am to explaining my data set. Here, R-squared gets closer to 1. Now, this is the theory. In practice, another factor that can push R-squared up to 1 is a growing variance. Indeed, for non-stationary time series, the value of R-squared can quickly grow close to 1 because of a larger variance and not necessarily because of a lower total error. And this can be deceiving when trying to get a reliable assessment of the model quality.